finally, question 9. We've got this bottle. We want to find, basically, its volume. So it's being rotated around the y-axis. So we split them into 3 bits. This bit up to FC, when that's rotated around the y-axis, that's just going to be a cylinder. This bit between H and G, or A and B, when that's rotated around, that's just going to be a cylinder. So we can work out the volume of that easy enough, pi r squared h. This bit is going to be the integral, or pi times integral of x squared to y, because that's rotated around the x-axis. So, part A, the student thinks geometric model by the curve with that equation where A and B are constants. Find A and B. We're given some boundary conditions somewhere. Where are they? Oh, it's from the numbers here. So we've got the point which is 1 across 18 up, half of 2 being 1 across 18 up, and then half of 8 being 4 across 14 up. So the point G is the point 118, and the point F is the point 414. We think it's being modelled by y is equal to ax squared plus b. So if we put those numbers into it, we get 18 is equal to a plus b, and 14 is equal to 16 a plus b, which we have to solve simultaneously. If we take one from the other there, we'll get that 15a is equal to minus 4. So a is equal to minus 4/15, and then we can sub that into that equation to work out that b is 274 over 15. So really the equation is y is equal to minus 4/15 x squared plus 274 over 15. So now, as I said, we've now got these cylinders. Think of this cylinder has a height of 10 and a radius of 1. So we'll call that volume AB. Can be a pi times radius squared times height, or as we more commonly call it, 10 pi. The volume from C to D, that's got a height of 14 and a radius of 4, so pi times 4 squared times 14. £224 pi. The curvy bit, which we'll call that BC, is pi, because we're rotating around the y-axis, pi x squared to y, which is going to be equal to pi times the integral of, if we rearrange this, we'll get 15y is equal to minus 4x squared plus 274. So that will be equal to 274 over 4 minus 15 over 4y to y, and we're integrating along the y-axis between 14 and 18. For the sake of simplicity, we'll whip that 4 outside. We can then integrate we can then say that's going to be equal to we can then work that out by whatever method best makes sense to us, but just quickly in my head I reckon that's 34 pi. So therefore the volume is equal to 10 pi plus 224 pi plus 34 pi, which is equal to 268 pi cubic centimeters. Stated limitation of the model, that could be anything between the measurements may not be accurate, the equation of the curve may not be suitable, the bottle may not be flat, the thickness of the glass hasn't been considered, the glass may not be smooth, but it's got to be something about dimensions or the model. The label on the bottle states it holds approximately 750 centimeters cubed of water. Using this information and you answer the part B, state whether there's a good or more, explain your reasoning. Well, that actually works out to be 842 centimeters cubed, 2 and 3 significant figures. So if you compare this to 750, you have to do a sum. It's not just enough to waffle about it. It's either take it away and say that it is, but basically there's two criteria. You've got to compare 800 and 750, not just percentage error or just a difference with no calculation, but you need to compare them, and then you need some conclusion stating that it is consistent with the values, that it is a good model.